Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 79 of mathematics. Today we are going to learn the remaining three quadrilaterals, and that will complete our set of 6 quadrilaterals. So let's get started. First, we are talking about the properties of square. The first property is there are two pairs of parallel lines. So you can see that this line is parallel to this line and this line is parallel to this line. In fact, all of them are of equal size. All four sides are of the same length. That is the second property as well. Third one, all four angles are right angles. You can see I denoted it with the red. All the four angles are right angle. Number 4 is the two diagonals are equal in length. So AC and BD are equal in length. Number 5 is diagonal bisect each other at right angle. So it means that they are dividing it into equal angles because each angle is of 90 degree. So one side, for example, this one will be of 45 and this one will also be of 45. So keep these things in mind. The sixth and the last one is diagonal bisect each other, each interior angles. So that is equal to 45. I told you. But one more is that this angle and this angle bisect each other at 90 degree. So you have to keep that in mind as well. Now let's turn our focus to the second quadrilaterals of today's lecture, and that is properties of rhombus. There are two pairs of parallel lines. You can say that very clearly. The second property is all four sides are of same length. Yes. Third number is opposite angles are equal. So this angle will be equal to this angle and this angle will be equal to this angle. You have to bear this in mind while solving the exercise questions. Number 4 is diagonal bisect each other at right angle, which is shown here that they are bisecting each other with 90 degree. Number 5 is diagonal bisect interior angle. So they are dividing the angle into equal parts. Remember these. Third one is, and the last one is trapezium. Now trapezium is that type of quadrilateral in which there are two parallel lines and two non-parallel lines. In this case, two parallel lines are AB and DC, and the two line AD and BC are non-parallel line. This trapezium is having only one property. There is at least one pair of parallel sides. So keep these properties in mind. Let us dive into exercise 11b, and the first question is on the square. They given us a square in which all the sides are equal, but keep in mind and pay full attention to diagonal DE. That is not a diagonal because it is not terminating at point B, which is the vertex of two lines AB and BC. So they made this trick that you people have to think not only by seeing the line which is intersecting each other, so they are the diagonal. No, they are not the diagonal. In this case, AC is the diagonal, but DF is not the diagonal. In this case, we have to find A, and we have to devise a plan for it. So first we have to find this one and then this, and through the triangles properties, the angle sum of interior angles of a triangle is equal to 180 degree. Now how we will find this? We said that I'm writing it so that you will understand. BAC angle is equal to DAC angle, which is equal to 45 degree, and I am writing diagonal. We studied this property. Diagonal bisect each other, each angle I should say, interior angle, bisect each angle. So it means that this will be equal to 45 degree, and we found it on a through proper channel. Now next is this one. So this can be found by a straight line theorem. So we can say that AED angle plus 82 degree is equal to 180 degree by angles on STR line. Angle on STR line. And now we can write AED is equal to 180 degree minus 82 degree, and that will be equal to 98 degree. So we also found this to be 98 degree. Now the next one is that we have to now find that A degree plus 45 degree plus 98 degree is equal to 180 degree. I am going on that side because the space beneath is reserved for other question. So when we calculate all these things on the calculator, we will get 37. You can confirm that with your calculator. I already did it on the calculator. So now we found A to be 37, and now we are going to find another angle, and that is B angle, which is this one, and that is B angle. So we have to find angle B, which is this one. This is not uppercase letter B, this is small b. Now we have to make a plan for it, and because ABCD is a square, so we can say that BAC because for this we have to find this angle, and then angle on a straight line theorem will be used, and we will find the value of B. But for that we have to do what? We have to write it here. I will shift that question B downward later on, but let us do the second part of this, and that is the first we are writing that BAC is equal to BAC is equal to another angle, and that is DAC, and both are equal to 45 degree. We learned that they are bisecting each other with. Now we got this angle to be 45. Now we have to find this angle, and that is ABF. ABF is equal to 82 degree, and that is vertically opposite angles. Vertically opposite angle. So you can say that we found. Now we have to find this angle very easily, which is AFE. AFE angle plus AFE plus 45 degree plus 82 degree is equal to 180 degree. And if we are finding FAFE, then after the necessary calculation we will be able to find that it is equal to 180 minus 82 degree minus 45 degree. We can do that in another way, easy way as well, but now we have started, so we are not changing our direction. So 180 minus 82, 98, 98 minus 45, and that will be 53. So now we found this is to be 53 degree. So B degree plus 53 degree is equal to 180 degree, and that will give us 127. So B degree is equal to 127 degree. We found it. Now I have to find the value of B. We have to turn our focus to, I miscalculated the space, so let's do something for the question. You have to note it, and then I will write it somewhere. So let us remove this area which you have probably done it, and let us do the remaining part B, in which there is another square given to us, and we have to find the value of unknown, that is C and D. Now these two C are given, so I can write C degree plus C degree plus 45 degree is equal to 180 degree. So I can write this as 2C degree is equal to 180 degree minus 45 degree, and then we have to calculate this 135, that is 135 and 135 divided by 2. I am doing it directly. Divide by 2, which will be equal to 76.5 degree. 76.5 degree. Okay, now we have to find the value of D. I can write here that D plus, and I will ask you D degree plus, and then I am writing 67.5 degree is equal to 90 degree. We are doing what? Because this angle is totally equal to 90 degree, we have studied this property. So D degree plus C degree, and we found C degree to be equal to 67.5. So now we are finding D degree is equal to 90 degree negative 67.5 degree, and the ultimate result will be 22.5 degree. So that's it for this question. Now we are turning our focus to question number 5, and which is totally dedicated to the rhombus. And in rhombus all the sides are equal. We have to keep this in mind, and opposite angles are equal. So the first part is very easy, and that is the question number 5 and A, because opposite angles are equal in magnitude, or you can find that sum of the interior angle, which cannot be applied here. So we are trying to find that. Simply I am writing that A degree is equal to 114 degree, and that is because opposite angles are equal. In case of rhombus, we studied that, and the second part is now we have to find B degree. So B degree plus 114 plus B degree. B degree plus 114 plus B degree is equal to 180 degree. Ladies and gentlemen, we have to give a look to the lower triangle, and you know that the angle sum of triangles is always equal to 180 degree. Because this is B, so this will also be B, and we have to write 2B degree is equal to 180 degree minus 114. When we calculate it, it will be equal to 66 degree. Now B degree is equal to 33 degree, because we have to divide both sides by the 2, which is the coefficient of B degree. Now we are turning our focus to the second part, and that is also a rhombus, in which all the sides are equal and the opposite angles are also equal. in this B case they given us that this is the D angle, this is the D angle, and this is the C angle, and then this angle is given as 38 degree. So these are all the information we are having for the solution. So let us do this question here. And you know that ABCD is a rhombus. So you have to consider this as the rhombus properties and mind, and those are not that much difficult. So we are going to write it here B, and I can write ACB angle is equal to ADC angle. ADC angle, because these are two parallel line and this is a transversal line. So we can say by the alternate angle that it is equal to what? It will be equal to 38. So we can find that as 38. So C degree is equal, I am writing 38 degree by alternate angles theorem, and I am writing 38 degree, and that's it. We found it very easily. Now it's the turn of D degree. So for D degree we found one this, and we can find this one as well, because the diagonal are bisecting the interior angle. So if this is 38, then this will also be 38, and we can easily find the next one. So this is, remember there is a trick involved, this is D, so this will also be D. So instead of finding this D, we can find this, and we can also find this D, because we found the value of this C, which is equal to 38. So this will also be equal to 38. So there are many ways in which you can find. So we are writing D degree plus 38 degree plus 38 degree, and that will be equal to 180 degree by the angle sum of triangles, and that is 180 degree. So D degree is equal to 180 degree minus 38 degree minus 38 degree, and we are going to find the final value, and that is 104. 104 is the ultimate answer. Let's turn our focus to part C of question number 5. In this case also we are having a rhombus. So we have to keep in mind the properties we learned earlier, the properties of rhombus. Now the situation is in front of you. They given us different angles, and we have to find E degree and F degree. So first of all, let us find E degree, and for that can we write DCA is equal to CAB, and can we write it to be 42? If yes, then alternate angle is the cause of it. Alternate angles theorem. Because DCA, which is our goal, and that must be equal to CAB, which is this one. Those are equal because these are parallel line and this is a transversal line. So through that we can find that C degree is equal to 42 degree. Now that's it for the first. Now it is the turn of F degree. So we are going to find and we can write A D B is equal to C D B, which is equal to F degree. Both are equal. A D B, which is F, and that is equal to C D B, which is this one, because they are bisecting each other, and I have to write it here. Diagonal bisect interior angle. So according to that we wrote F. First we specified, and we can write that AD is equal to CD. AD is equal to CD. So we can write CAD is equal to ACD. CAD, which is this one, which is equal to ACD, which is this one. These angles are equal. So now we can write that both of them are equal to 42 degree. We found that. And now we can write F degree plus F degree, because these angles, we said at the beginning that these are equal to F. So F plus F degree plus 42 degree, which we have found this one, and I am writing from this area. That will be equal to 180 degree, and that is angle sum of triangles. Now I am writing 2F degree is equal to 180 degree minus 42 degree, which will be equal to 42 plus 4, because this one is also 42. So here we have to write, because this is 42 and this is also 42. So we have to write 2 times 42 degree. So here I will write 2 times, this will be negative, and 42 degree, and that will be equal to 96 degree. Yes, and F degree is equal to 48. So by using different techniques we found the value of this. Now there is another question which is containing two parts, and the time is not allowing me to do this question, so let us leave it for tomorrow's lecture and let us finish it here today. So that's it for today. Thank you very much for watching. Have a nice time. Bye bye.